Operational Efficiency and Sustainable Design. Welcome to Building Knowledge 101. In this video, we look at the critical issue of energy efficiency when designing sustainable building envelopes in the educational sector, addressing heat transfer through conduction, convection, and radiation. Energy efficiency is critical to a sustainable building envelope. Energy is costly, but is required to heat during the winter and cool during the summer. Heat always moves from the warm to the cold. It takes energy to heat and energy to cool buildings. So we want to build building envelopes as thermally efficient as we can, creating an efficient wall section that maintains a separation between the warm sides and the cold sides. So how does heat transfer? There are three methods of heat transfer. The first is via conduction. This is heat transferring through molecular interaction of solid material. Here you can see a section cut through a horizontal. Aluminum is very conductive, so heat is going to flow very easily from the warm side to the cold exterior. Here's a thermal image that shows heat warming the exterior of a frame. So you can see that heat is being pulled through the section cut. It's a non-thermal section cut, so heat is being pulled through, and the exterior of the frame is being warmed by heat being drawn through. The second method of heat transfer is via convection. This is heat transferred via molecular turnover in a fluid environment. Here we have a section cut showing a warm side to the interior and a cold side to the exterior. Air circulates within the frame section from the cold to the warm, transferring heat as it rotates. The third method is called radiation. Direct sunlight and glass can radiate heat to the interior. Your strategy to address heat transfer can vary by location. Here on the left is a project in the cold of Colorado Springs. On the right here is a project in the heat of Sarasota, Florida. In Colorado Springs, we're concerned about keeping cold out and warm inside. Where in Sarasota, we're concerned about keeping heat out and cold in. So again, your strategy is going to be based on where you are geographically. The scale shown here on the right reflects the temperature dispersion used in the industry standard thermal test. This ranges from 0 degrees, shown in black at the top, to 7 degrees, shown as red at the bottom. The thermal image here shows that heat is flowing through this frame section from the warm side to the right to the cold side to the left. The exterior of the non-thermal frame section is warmer than the surrounding air. In this section cut of a thermally broken frame, you can see that the lines converge at the thermal break. There's a low conductive material introduced here that is slowing down the transfer of heat through this section. In this section cut, note that the left side is the exterior is darker, closer to black, indicating that it is colder, matching that of the temperature in the surrounding air. So heat is not flowing through this section cut. Here you can see a section of commercial aluminum frame with a thermal break in it. Clearly, this shows how conductive aluminum can be. See, the frost is traveling up the frame section, but then stops when it hits the low conductive pour-into-bridge thermal break in the frame. That is all we have time for in this video. If you'd like to watch more of our 101 video series, subscribe to our YouTube channel, Kawneer Company, Inc.